Did you know that 1 in 4 people carry disease-causing mutations? Well, Bonnie, the founder of Vertility Health, did. And she's here to revolutionize genetic screening. Let's give a big round of applause to Bonnie, the founder of Vertility Health.
Thank you to the organizers for having me here today. My name is Bonnie Maven, and I'm the CEO and founder of Vertility Health, and we think a lot about sperm genetics and the future of disease prevention. So our mission is that we are creating a future free from hereditary diseases with our novel and innovative DNA-based sperm sorting method. This is critical because there are over 7,000 known genetic diseases that parents can pass on to their biological children. An example of this is the homozygous recessive disorder sickle cell anemia, where each male and female sperm parent, or male and female parent, must pass on the mutation for the disease to manifest in the child. Traditionally, couples can avoid this by going through in vitro fertilization, or IVF, where the individual embryos are actually sequenced and can be selected against if they have the condition. And while this is very effective, it still is very costly, time-consuming, and very physically demanding and intensive. And so our solution, our approach, is actually a bit different. Instead of at the embryo level, we're doing the selection process at the sperm level. And so what we're doing is actually isolating sperm free from genetic mutations, ensuring we only have the healthy ones. So for instance, we start with a pool of healthy sperm, and then using our proprietary method, we tag the ones that have the specific mutation of interest and remove those from the sperm, from the pool. And so what we're left with is a pool of healthy sperm. And the significance of this is that with this pool, we actually don't need IVF. We can just go forward with a direct insemination, commonly known as IUI, or intrauterine insemination, which allows us to bypass IVF, increasing the accessibility of this kind of treatment globally. So this solution is much more affordable, much less physically demanding, and importantly, scalable and easy to implement, which means we can get it to the couples faster. So we are a science-driven team. I have a PhD in understanding the inner workings of DNA from UCSF and Gladstone Institutes. I'm also joined by my scientific advisor, Nadja Manowitz, who is the CSO and co-founder of Your Choice Therapeutics, an awesome male contraceptive pill company. We are also delighted to have David Sable as our industry mentor, who is really a key thought leader in this space. So to go over a brief overview of how the technology works is we must know the genetic mutation of interest. And what we do is we actually custom design a specific small molecule to bind to that mutation. And once it binds, it then fluoresces or glows. And that's how we're able to target the sperm that we then remove. So right now we are finishing up phase 1, and our animal model is actually the bovine, so hence the song, and actually specifically cattle, because their sperm is actually really similar to human sperm. And so what we have now is this small molecule actually designed to target Y chromosome sequences, so we can distinguish which sperm have the Y versus X chromosome. We're excited to move into the next phase, and since cattle don't really have genetic diseases like humans, I'm actually instead targeting the gene that codes for whether the cattle have horns or not, since farmers don't want their cattle to have horns for safety reasons. But I'm really excited to then use our optimized technology to go into the human model, where our first target is sickle cell anemia, the most prevalent genetic disease in the world. Our business model is actually an off-site sorting facility where the fertility clinic itself will actually do the sperm collection, send it out, and sperm shipping is quite routine, send it out to the accredited sorting lab to then perform the sort. And then that sorting facility will then send it back to the fertility clinic to do the insemination. So this technology provides a more accessible, scalable, and patient-friendly option for so many prospective parents, as confirmed by a lab director at a leading US fertility clinic. So again, to compare our technology to this embryo sequencing technology I mentioned earlier, not only is ours much more affordable because we're avoiding the whole IVF process, but also it can be a lot quicker. So the test development is immediate. We only need to know the exact genetic mutation, and the turnaround time is very quick. The sperm sorting process is a very fast and rapid process. And so speaking to UK customers or couples directly, their main concerns are getting to treatment faster and really ease of use or simplicity, which our technology targets both of those. So one reason I joined the Femtech Lab program was really to get an overview of the global interest in this kind of technology, to see what the global market is. And so I'm giving you a wide overview of what the market is that we hope to achieve one day. So 10% of couples actually are at risk of passing on a hereditary condition or disease through the sperm. And so what this means is that our technology could help up to 13 million couples worldwide every year. So this gives us a total market of $134 billion. So through surveys, we know that about a third of the couples actually know that they are at risk of passing on a genetic condition, which narrows our market to 45 billion. And actually our initial strategy to get this out is to start with couples that are already at the fertility clinic, which is about 1 in 6. And so this initial market is then 8 billion. In addition to human health, we're also exploring licensing opportunities in the agriculture market. So the ask is £400,000 for a pre-seed. This gives us a 12-month runway and the ability to hire another scientist to accelerate this work. It'll also allow us to complete our animal model MVP for, again, the pulled horn, and then allow us to do early-stage animal IVF clinical trials. And then I'm excited to use this technology in human models for sickle cell anemia. And this will all go into our utility patent, our patent portfolio. So, there we go. Thank you for your attention. I'm happy to take any questions.
Thank you. That was a really good pitch. I'm curious about the regulatory landscape for this, because I'm sure we don't want to be able to screen out everything, or do we? Or what's your thoughts on like the regulatory landscape, what it's like and what it maybe should be like?
That's a very fantastic question. So I'm based in the US, and so the regulatory landscape there is a bit different than worldwide. Each country seems to have their own methods of determining how this would be regulated. In the US, this would actually be classified as a sperm sorting device, and so the regulatory pathway there is actually quite straightforward. But talking to fertility clinics, they really want to see the data. They want to see it published, that this works, it's safe, it's effective, and so that's built within our plans. In terms of the ethics side of it, it's a great question, and this could absolutely be abused by people to select for traits that are not for diseases. And that's why it's so critical for us to build an ethics panel early on, which is something I'm already thinking about a lot these days, and how I want that to be unfolded.
Thank you. That was a great pitch. So you just touched on there how the clinics are looking to see more data in order to incorporate it. So I suppose how well defined are the genetic mutations that you're going after for the hereditary diseases associated with the sperm?
Sorry.
How well defined? How do you know exactly what you're going after with the genetic mutations? Is there strong links between that and a hereditary disease?
Oh, yes. So thank you so much. So a lot of DNA sequencing companies will, instead of actually sequencing the genetic mutation, they will sequence what's called a small nucleotide polymorphism, or SNP, that's upstream or downstream to do associations. So fortunately, for most carrier screening companies, they actually do the full gene sequencing, and they know what the exact mutation is. And so that kind of information is what we are going after, of the exact mutation, not an association.
Sorry, positioned awkwardly at the back. Really love the presentation, Bonnie, and I think what you're creating is great. I had a quick question. Are you just focusing on sperm and then Y-linked associated diseases, or are you hoping in the future to expand into X-linked conditions which are passed down through the female line, and also conditions which are carried through mitochondrial DNA, for example?
This is a really great question, and fertility clinics that I've talked to, in case anyone else is interested in starting a company, really want there to be better pre-implantation genetic diagnostic testing, something that they can do in-house in the fertility clinic. And so it's definitely possible to use this technology for that approach. I will say our technology is specifically designed within the sperm DNA, which is actually quite different from most other mammalian DNA types. And so we haven't exactly explored that, but it's definitely something I've been thinking about. Thank you so much.